Okay, so this is the part making part of my series, and this is going to be a pretty long video. Well, actually, I don't know how long it's going to be, but my guess is it's going to be pretty long. And I'm also eating ice cream on the side right now, so I'm taking my sweet old time with this, okay? Okay. So before I get started, I think it's important for you guys to understand how we make these parts. And what I mean by that is by just looking at a couple of examples and understanding what we do. So this is probably like the 10 millionth time that you've seen this design, well, this robot. And yes, I know you guys probably know like literally everything on the robot, but I just want to show it to you guys again, just to point out a few things. So number one, these intake pieces were custom made, like custom CADed, I guess, and custom made. These arms, these walls, shooter walls, these brackets on the side over there, these limelight mounts on those sides. You guys get the point. So I would say just around 40% of the robot is actually like custom made, which is why making parts is very important. And I know that I said in the meetings that I don't really care that much. Yeah, don't listen to that me was delusional. 40% of the robot is custom parts. So it's very important that you understand how to make these parts instead of wasting your time, because I don't want you guys to get burned out. CAD burnout is real. It's worse than senioritis, because trust me, I've had it twice actually, and it's pretty bad. So I want you guys to learn how to make these properly. And what I mean by that, by properly, is by making them as efficiently as possible. So let me give you an example. Let's say I wanted to make a spacer, and what spacer should I do? Actually, I don't really know any. I guess there's spacers up here which I can use. Oh, I know one. There's one right here. Is it on this side? No, it's on this side, right? Right. So this one was a spacer that I made. Wait, no. Where did the spacer go? Where are my spacers? I know there's one right here. Just okay. Well, I have a spacer right here. So let's say I wanted to make a spacer, and it's just a point where or like here's another spacer like right here. So it's just a way to create pressure between two spaces, right? So let's say I wanted to make that. So I would start with a sketch, obviously. So enter the 2D world, and I would draw my circle over here, right? And then extrude it out like this, and then put another sketch on that, and then create another circle here, which is kind of invisible. This is kind of invisible to see. Here, I'll do that again, like that. Another circle, and then extrude that, make a hole like that, and boom, I have myself a spacer. Did you notice how annoying that was to make this one simple part? And that was pretty time consuming, right? That took me right around, I don't know, it felt like 30 seconds probably to make it. I'm gonna take another bite of my ice cream. It's Mackinac fudge, by the way, so it's, I just have to. So notice how time consuming that was, and think about how many parts here that you actually have to make. So I want to show you guys how to make these parts efficiently, and a good example is by just looking at the parts that I made on here. So this is the one of the intake arms, and yes, this looks kind of bad, but for considering how complex this is, I would say 17 extrudes is not bad at all. So we always start off with like everything that we know is going to be on the part, we CAD that in on the first sketch, because notice how as soon as I extrude that, I already have the main shape done. Notice how the shape between now and the holes between now and this final piece have not changed at all. That's called efficiency, because we don't want to do any adjusting later on in the 3D menu. We'd rather just finish everything in Sketch and be done with it, right? A bad example, this is another good example. This is just 3 extrudes. I did this entire model in 3 extrudes. I got better once I started doing the arm. I was a beginner here, and then I got better over here. A really, really bad example, and I'm not ashamed to say it, actually I very much am, is this. I present to you 53 extrudes and 39 sketches to make this limelight mount. And if you're not aware of what that is, that's this thing back here. It's meant to, I don't know why this limelight's just floating, but it's supposed to hold this limelight camera thing, and it's supposed to be back here. That took 57 extrudes, full 53 extrudes for one singular part. That's horrible. Don't do that to yourself. After doing this design, I actually wanted to die, because this was such a waste of time. Like, I might have just spent over 2.5 hours on a single part, and that single thought alone made me want to jump off a cliff, because don't spend that much time on a single part. That's way too much time for something as simple as this. Something like this, sure, because you're going to run through iterations a lot of times. That's normal. But on a single 3D printed part that you kind of already know everything about, wasting 2.5 hours on this is crazy. Don't ever put yourself through that. It's not going to be fun. I guarantee you. I'm going to take another bite out of my ice cream here. Make that 2, actually. So, what caused me to make this 53 extrudes long for this simple part? Well, I wouldn't say simple, but it looks basic enough, right? Well, the problem was, I started making it instead of, like, think of it like a 3D printer, right? That's basically what I was doing for this design. I was just going through and extruding every single part that I knew. So before long, I just started creating parts of it, right? I started making the part. No, don't do that. And you're like, what? You're like, what the hell? Aren't you supposed to make a part? What are you supposed to do then? And I'm telling you, no, you don't make. Well, in this case, in simple cases, yeah, sure, go for it. In this case, like for this, there's a lot easier way to do this. Imagine if I just drew a triangular prism from here, draw 3 lines in a sketch, made a triangular prism, and then just extruded it. So I had a triangular prism like this. Here, I'll just do it again. I'll just show you guys what I mean over here. Imagine if I just had a triangular prism that just looked like that. And then I extruded it to the length that I needed. So imagine that. And then I started removing stuff from this one triangular prism. I could have saved so much time instead of just manually extruding everything to build it. I was trying to build something in here. Here, I'm just trying to break stuff. And just think of it logically. Is it easier to build something or to break something? Obviously, to break something, right? So, it would have been a lot easier if I just started carving out this piece, one piece, like CNC. I can't believe I said one piece, and I just thought of the anime. Oh my god. Okay, but carve out this piece, right? Like a CNC machine. Just imagine carving it out compared to a 3D printer that makes the part, which is what I did here, which turned out to be hell. So don't do that to yourself. Spend the first 10 minutes of making a part just thinking about how you're going to make it efficient, because I'm telling you, CAD burnout is very much a real thing. I'm going to take another bite out of my ice cream, by the way. Mm, mm, mm. Mm, 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 mm. And another, actually. So, I think you guys get what I mean. So back to my original piece over here. How could I have made this more simple? And the answer is, I could have just done this in one sketch and an extrude. If I go back in here and then just draw another circle here, and then extrude the outside, I just did in 2 steps instead of 1, and instead of in 4. So try to make your parts as efficient as possible, because it's just going to hurt yourself if you make it complicated, right? So that's pretty much what I'm trying to show you guys. Okay, so let's get into actual part making. I probably just wasted like, oh my god, 10 minutes on that yap, but alright, let's get started. Okay, so these are the tools that you use for the 3D world. We do not use all of them. Like, if you just look at what I've done over here, we just use extrudes. Over here, we just use extrudes. Over here, we kind of just used extrudes and some filleting. Yeah, and some chamfer. That's it. We really... Don't worry about this. This is nasty. Don't worry about that. We really do not use any of the other 3D tools. And that's simply because we don't design anything where we need those 3D tools. So, really, you don't need to know all of them. You only need to know like 4 of them, because that's really all that we use. So let's get started. So let's go into our 2D world, and I'm just going to make some random sketches. So maybe a corner rectangle here. Don't forget your hotkeys, by the way. Another rectangle there, and maybe a circle like that. Let's call it a day. So now that we have our 2D shape over here, we need to make this 3D. And there's many ways to do it, but the most common way, and probably the only way that we do it, is through extrude, which is Shift E. Or you can go up here and click this cube looking thing. That also does the same thing. So extrude, you can notice how it says faces and sketch regions to extrude. So you can extrude any faces, so like if you already had a part, which I'll show pretty soon, or sketch regions like this. So this is a region that we can extrude because you can see the highlighted area. And that basically tells us that it can be extruded. So we can also go along here and just follow it around. I'm just going to extrude this and call it a day. And you can use this arrow and change the direction of the way you want to extrude. Or you can use this button to change direction. And you can type in a depth of whatever you want, and it just does it for you. You don't need to worry about direction. Not really something useful for this. Starting offset, if you want to make a little offset from your sketch or face, you can definitely do that. I've never used this ever, so don't worry about it. Symmetric, if you want to do it from both sides, you can do that too. And then draft, I've never found a use for it, like, honestly. It just makes like that angle, I guess it's just called draft. It just starts making that angle thing. It makes it go outwards, like a bowl, right? That's what draft is. I've never used that either. Again, I'm telling you guys, what we do is very limited, but for a good reason. So let's just stick with that, and we call it done. So we have here our little part. So congrats, we basically made our first little part here, right? I want to go back here and I want to show you some mistakes that you might have made while you were extruding your part or whatever. Notice when, here, I'm going to do this instead. Or maybe I'll do this. This is easier to understand. Notice when I was making, notice how when I just extruded, well, I undid those ones. You can undo them by clicking on it again, by the way. So if I just unclick that, you can undo your extrude. So Notice how I have these two faces selected, but they're different colors. And that's because when we have the new option in Extrude enabled, that basically is telling Onshape, yes, we want to make a new part, right? So Onshape is looking here, looking around, inspecting it, and seeing that, oh, we don't have anything that's physically connecting these two parts together, so it's assuming that they're two separate parts, which is right? Because if I finish, notice how we have two separate parts now, part 1 and then part 2, because they're not connected together. So if you go back in Extrude and connect them like that, now it's just one singular part. Another feature that you can do is the add feature, which automatically does it if you just click on a face of a part. You can also click new, and then it just separates it. So now we have a separate part here compared to this one, and that comes into use, like separate parts, when you go into assemblies, which we'll talk about later. But that's basically what's going on there. Revolve is just, it's in the name, it makes something revolve. So if you click an axis to revolve around, you can revolve that face or whatever that you want. It can be a sketch or it can be a 3D face. It really just depends on what you want to do. So you can revolve like that. You can also press new for this and it create a new part if you want, or you could do the remove feature, and that removes stuff from a part. And notice something. This gray part is being removed, but not the blue. And that's because there's something here called merge scope, and that means you can select what you want your extrude to affect. So in this case, the only thing it's affecting is part 2. So if we click merge with all, now it's affecting all of the parts, right? So it's something pretty cool. Intersect, you don't need to worry about it. Or surface and thin, also stuff that we never use. So really it's just these 3 things that you need to know. So yeah, we have ourselves a little shape here that looks very weird, but we have a piece. We have a little part here. Next up, we don't really use these fillets. We just do them for, honestly, my reason for using fillets is to just make everything look cool. That's not the reason that we actually do fillets. It's to create structural integrity, or to remove sharp corners. I'm gonna take another gulp of my ice cream, by the way. So fillets to remove sharp corners. That's usually fillets. Yeah, so that made no sense. Oh my god. Okay, so fillets to remove sharp corners. So let's say we're making this part out of metal. We put fillets here to tell mechanical, okay, deburr the side so we don't hurt anyone. And that's actually a rule in FRC, that there should be no sharp corners on the robot. That is the actual rule. Another way you use fillets is through corners to strengthen them. So here's a good example. This creates a lot of structural rigidity for the part compared to if you just had this corner. It's easier to break this piece off. Like, imagine just snapping this piece right here and creating a crack like that. It's a lot easier to just put a fillet here, and then that spreads the load to this piece as well. So that's what fillets can be used for. Chamfer is similar to fillet. You might use it sometimes. It's for the same reason too. For like structural rigidity or anything. You can change the distance to whatever you want it to be. I'm gonna go like 6 inches. But yeah, that's just what chamfer is. We don't really use the other ones. Oh, linear pattern's important. So if you want to replicate your part, just go ahead and you can either click here and then multi-click the other ones, or you can just drag all over it and then click linear pattern, and you can make a pattern of these parts. And you can do that through selecting the parts that you want to pattern. It doesn't have to be all of them. You can just select certain ones, select a direction, so just select a line that points in the direction that you want to go. So in this case, by selecting this line, I'm saying I want the linear pattern to either go up or down, right? Because this line goes up and down, right? Let's make this like 6, and then make the distance between each of them like, I don't know, 10 inches. And I have 10 of these now, look at that. And you can also change the direction of how it makes a pattern, which is pretty cool. You can also do these other ones. You can also do the add feature, but it would not work. And that's simply because they're not connected to each other. So if I just press OK, it still made separate parts of each other, right? Even though I pressed add. I said add, but it did not know what to do with it. Right? So if I go back and change the distance to, I don't know, 4 inches or something, notice how it's all one part again. That's what add and new. That's what the difference is. Anyways, so that's linear pattern. You also have the mirror feature. So if you just select the parts that you want to mirror, I'm just going to mirror this. And then find a plane that you want to mirror it on. Let's just mirror it on this plane. Notice how it just does the same thing and just flips it around. That's what mirror is for, right? It's just a mirror. So it's pretty cool. That's another feature that we use a lot. But other than that, that's pretty much all the features that we use like for part making. And it gets a lot more complex because you can change like the faces. You can adjust the faces of parts, so you can extrude this face and then make it longer, right? And then maybe revolve it around this axis, and then instead of one direction, and then just change it to like something like that, right? It gets pretty complicated, but those are the simple tools that we use, and then using those tools we make complicated shapes. So simple tools to make complicated shapes. It's pretty simple. So next up, we have probably the most important thing, because like I said, a lot of the parts that we make are usually just editing pre-made parts. So like notice how we have this 2x1 here and we just put some holes in it. How do we do that? Or this 2x1 over here, how did we put cutouts in it, right? So how did we edit these pre-made parts? And we actually do that through the derive feature. And the derive feature basically means we're going to grab parts from other places. So what I mean by that, once I take another gulp of my ice cream. Oh my god. Alright, so let's say I'm importing this 2x1. I'm going to make it 16 inches long or something. Generate. And I import this aluminum tube in. So notice how this aluminum tube is now in a part studio. And you can also do that with CAD parts too. So if you just go to the CAD deriver, which you should have, go to any part that you want. This one. Notice how it just places it in there, like this. And then using this part, you can edit it. So I'm going to just hide this, and I can create my own sketch on this, and I can mess around with it all that I want. Or even extrude on this. It all works out the same, right? So that's actually how we start manipulating parts. So by importing them with the derive tool, or you can use the CAD deriver over here. We use this tool for our own custom parts or any other global parts from like other people that are in MKCAD, or we can use the MKCAD driver and just click and it'll place it in here. So let's say I want to edit this 2x1, right? It's a similar concept. So I can just create a sketch on the actual part and then just start messing around with it. So I can make a hole over here and then a hole over here. Let's just call that done, and then extrude these holes, but use the remove feature to actually remove pieces of the 2x1, and look at that. We made cuts in our 2x1. Right? So that's actually how we manipulate actual parts. So that's really what we do most of the time. So like these holes over here, right? We did that similar concept, and literally almost everything here has been somehow modified in CAD, right? So this is how we do it. So you import one of our pre-made parts either from MKCAD or derive it, and then we just start messing around with it. I can do another sketch and, you know, maybe just cut a piece off of it. So complete the shape over here, and then I can extrude it and then remove, and I have myself a little wedge, which is very sharp, by the way. That tip is very sharp. So according to FRC rules, we would have to fillet this and this, probably like maybe 0.25, like that. We wouldn't have to do this one that much, but you guys get what I mean. So that's how we edit parts like that. So I'm just gonna go ahead and delete everything. And then finally, and this is something pretty, you guys won't use it that much, but if you do, there's something here called the robot belt, and you don't have it, so I will put the link for this robot belt in the description, and you just paste that URL in here and you just add it. And let me see if it's robot belt. I wonder if it's there. No, I'm not sure. I'll put the link in the description and how to install it, and you guys can do it. But this is a separate part making script which was made by the community, and this is actually how I make belts. So you can mess around with it, put I don't know, you can create relationships with belts and stuff, and it's pretty cool. So this is the belt maker that we use, and that's what we did over here for these ones on the intake. So that's what we did over there. We just used this, and then we just defined the belt sizing and stuff. And notice the length over here, it has to be exact when we're constraining these ends together. They have to be exact. So that's the other thing about part making. But other than that, that's pretty much it for part making. We don't really use any of these other features just because we've never found a use for it. But you can, if you want to learn it, be my guest, you know? So that's pretty much it for this video. I'll see you guys in the next one.